I am Anil Kumar. Let me thank all my viewers and subscribers on the YouTube channel to make this channel so special. I am really grateful to you. Today, we have crossed 200,000 subscribers, and these videos are being watched in more than 80 countries. Here is something special for you on the occasion of Father's Day. I thought we'll begin with some basic lessons so that anybody who is interested in mathematics can join us and learn as we move along. In this series, we are going to touch upon the important concepts which, if we learn early on, we can actually do very well in mathematics at least. You'll actually perform much better in other subjects also, even in your life. So, what I'm saying here is that skills required for understanding the videos in this series is just grade 5. So if you know basic arithmetic of addition, subtraction, multiplication, and division, you will be able to understand the topics which I have written on this particular screen for today and many more to come. So what we will actually learn here is all about critical thinking. Mathematics is a very logical language, right? And it actually helps us to understand the real life situation and to solve problems which come in real life. Not only solve, but rather, I should say, enjoy the life as such. What is around us, if we observe, then mathematics can actually help us to appreciate it better. We will see how in today's lesson and then continue with this plan, taking more concepts. So today we'll focus on counting techniques. There are many counting techniques, some complicated ones, but we'll keep it very simple. And the examples taken are like we watch every day handshakes, right? How many people in a party are shaking hands, and how do we figure this out? We'll see it right in the beginning. We'll see like how many lines can be drawn given some points, how many diagonals can be there in a polygon, how many triangles could be there in a two-dimensional figure, and how many paths could be there in a network of maze. Well, all these concepts will bring us to something very special. And we'll introduce to you factorial notation because in the above examples which I am talking about, we'll be dealing with large numbers. Imagine a party of 1,000 people. How many handshakes will take place? Well, very big number indeed, right? How do we represent these big numbers is factorial notation, which we'll try to understand, right? So in this first part, we are only observing, learning, trying to understand, and we're also understanding what is critical thinking and how do we think better and apply it to solve problems as we move along. Rather, I should say what? Appreciate nature. It's all about appreciating things around us. Well, if you do that, you can always beat the competition. It doesn't matter whether it is Olympiad or Math Kangaroo or Waterloo exam or whatever. You will be in a position to really perform much, much better in any competition. In life, learning should be assessed, and therefore, we'll have an assignment for you. Now, these assignments could also be done in groups, and I'll encourage for some of you to form small groups and do presentations amongst themselves, right? So during this time of COVID, you're not going to school, you are all sitting at home, but you have learned this art of online classes. That should help you to form some groups and then have a discussion on today's lesson. You could share these links with me. I will be highly I'll highly appreciate your activity and I'm extremely happy if you can do that. I like to join them. We'll end up with a project. Now, this project could be done as a model also. It might require few days to do sometimes. So we'll discuss your assignment and project next week. Perfect. And then continue with our lesson. Next week, we'll talk about Pascal's triangle. Very interesting topic. Well, let's begin. Story of five friends. Am I on the right page? What do you think? Are we trying to connect with mathematics with this? Well, it makes you think, right? Story of five friends. We're talking about mathematics. From where do we get this? Story of five friends. Well, first thing first, I've made you think, right? The whole idea of this particular series is to make you think and to get involved, right? So that serves the purpose. It should be the right page of this particular lesson, right? So we have started thinking about, does it link to what we're trying to say? I'm saying here, Anil, Ben, Chandra, Dev, and Irin meet after a long time. Wow. Okay, let's move on. Hmm, you must be wondering, how does that connect with the math class? Story and mathematics? That's what I meant, right? Are you wondering? Yes, you are. And that's the base of thinking. When you wonder, you try to analyze. And that's where the brains, the neurons start working. And you start thinking. Once you are in the state of thinking, then the learning begins. And that's where we'll begin our lesson. Perfect? So, are you ready? Yes, we are on the right track. The key words here are think and connect. I hope we get a connection, right? So, so we are now connected. So let's move forward. How is this connection going to help us? Well, as I said, we'll talk about the story of five friends. Anil, Ben, Chandra, Dev, and Iran meet after a long time. Right. And we'll start thinking whether this belongs to this chapter or not, or today's lesson. It does, as we realize that first thing, we are wondering and then we are thinking. The process has started. Mathematics is a language, just like any other language, that will help us to connect to the real world around us and model the situations to predict even the future, right? So, not only understand the situation, but also to predict what is going to come. That's very interesting. Now, as we move along, I'd like you to do one thing, and that is get ready for today's lesson. Now, when I say get ready, it means take a notebook and pencil to capture the thoughts. I know you have started thinking, but it's a good idea to capture these thoughts. I'll call them as our notes. And these can be very handy at times and also help you perform better in many ways, which you'll definitely realize in next 10 minutes. Right. So I like you to take a notebook and a pencil to capture the thoughts. First thing first, what did we learn so far? Well, critical thinking, think and connect. So put it on the top of your page. So you don't have to write everything I speak. You just have to jot down the points which make sense and which can reveal a story, correct? And connect you with at least today's class. And then you see how it gets involved in your own life. So, think and connect is the first thing we learn in today's lesson. And the idea here is to explore, to observe, to investigate, to visualize, and to discover. That is the whole idea. When we look into the story of five friends, you get the idea, right? So if you kind of interpret today's lesson in this fashion and keep on making notes as we move along, you'll also make a wonderful document and help understand what we are talking about, correct? As I said early on, this class is for anybody and everybody globally. If you know a little bit of mathematics, even then you can continue with the class. So let's continue now. I hope you're ready with these notes, right? So, are we all together in this journey? And so it is important for you to participate actively and to share the passion of learning, right? Okay. So let's talking about these five friends. First thing first, when they meet, what do they do? Hmm. Okay. So when these five friends, Anil, Ben, Chandra, Dev, and Iren, meet after a long time, they greet with handshake. That's what they do when they meet. Sophia observes them shaking hands and then wondered how many handshakes are possible among these five friends? So a question comes to your mind, right? When you watch somebody doing some activity, sometimes the questions pop up. And it keeps on going till we get the answer of that solution. That's how our minds work, especially when they're active. So this process of handshakes brings a question in the mind. That is, five friends. How many handshakes? Can you tell me how many handshakes can take place between the five friends? Let's try to analyze this, right? See, I've taken the names as Anil. So let's say Anil is first to arrive. Now, is there any handshake with Anil? He's alone, so no handshake, right? So, right, zero handshakes when Anil is there. Now, Ben comes in. So, when Ben comes in, then at least there is one, rather, I will say at the most one, or exactly one handshake. So, we have one handshake. Perfect. And now, Chandra comes in. When Chandra comes in, there are already two people, Anil and Ben, so Chandra will do handshakes with both of them. So that adds to the number of handshakes by two more. That's correct. Now, next, Dev comes in, and when Dev comes in, he will do handshakes with the three friends who are already there. Perfect. Three already there, so three more handshakes. And at the end, we see that Irin comes in. And Irin has to shake hands, rather loves to shake hands with his friends who are already there, four of them. Perfect. By a simple logic, we came to the conclusion. The number of handshakes are how many? Well, we just need to add these numbers 0, 1, 2, 3, and 4. Okay, 336 plus 4 is 10, and therefore we have 10 handshakes in these five friends. Do you see that? It wasn't difficult at all, but it gives you a method of counting, and that is what we are talking about. And see the result. It is so interesting. 1 plus 2 plus 3 plus 4. So I'm going to keep only natural numbers in our discussion today. So we'll say, well, if there are five friends, how many handshakes? We get 1 plus 2 plus 3 plus 4. Right. If we consider 0, that makes it whole numbers, so 0 plus this, right? So let's keep our discussion restricted to whole numbers today. Is that clear to you? You also understand that natural numbers do not include 0, but whole numbers do. Well, so it is basically, if there are five friends, then it is sum of numbers till 4, right? Because 0 was the handshake with the person alone. Makes sense? Now, if we know this part, can we extend this to, let's say, 50, 100, 1,000? Yes, we can. You got it. Perfect. So let's move on. So first, let's see, what did we learn just now? Right? So the idea here is placed in the form of an example. And that is what I'm going to do. I'm going to write specifically the example so that you can see and also understand, right? Many of you may not understand my accent, and therefore it becomes very important for me to write it down and show it to you. What am I trying to say? Well, here it is. We're talking about the handshakes, and the question which came in Sophia's mind is listed here. When she saw Anil, Ben, Chandra, Dev, and Erin meet after a long time, they greet with handshakes. The question is, how many handshakes take place among the five friends? So I've given you a multiple choice question. I've given you, well, A, B, C, D, E are five options, and we figured it out that it is option C, 10 handshakes, correct? And how did we work it out? Alone, one friend comes in, the second one comes in, the third one, the fourth one, and all handshakes are there. Perfect. Adding the natural numbers. So, what we did here is we need to add numbers up to 5, oh sorry, 5 minus 1, right? Because with the person alone, there is no handshake. Does it make sense to you? So if I have n persons, in that case, how many handshakes will take place for you to figure out, correct? Was it difficult? I think that was the simplest thing we could have done, right? Okay, let's move on. So what I did here is that I have shown you the illustration of what we just now did, right? So when Anil came in, a person alone, there is no handshake and the number of handshakes is 0. So the idea is when you're trying to analyze, there are different formats in which you could do it. Now, table helps us to put the information and analyze. So this is one of our tools, right? That is, make a table. So when you make a table, you can see a pattern, and that can help you to analyze, right? And get the result. You get the idea. So this is mathematical way of thinking, right? So what we have done here is we made a table to solve handshakes problem. So when the second person came, there was one handshake, right? That is the first handshake. Now when the third person came, there were two already, so we added two handshakes. And so when you add two handshakes, you get three handshakes in all. Perfect. When the fourth person came, since there were three people already, three more handshakes, right? So 3 plus 3 is 6. And with the fifth person, four friends were already there, and that four gets added, and you get 10 handshakes. Looking into the options, this is the type of question you see in Olympiad, for example, right? In SAT, for example, right? Even in IIT JEE sometimes. This type of question can be a part of the question. Do you realize? So we are actually not just in middle school, but we are aiming for very high. That's the whole objective, right? Now, as you said, we want to really extend this to many persons. Let us extend it to 50 persons. How many handshakes take place if there are 50 persons, right? That's the whole idea. Are you ready? Right? Did you take notes? It's very important to continue taking notes, right? At the end, we are going to discuss even the notes, and that will be a part of your assignment. Remember this, okay? Well, that brings us to the second example. And you know what is our second example? We just want to extend the number of persons in a meeting, and this time we'll keep it to 50. A small room, right? Okay, not that small though. Okay, definitely not an auditorium, right? There could be an auditorium also. So, how many handshakes will take place between 50 persons if exactly one handshake is done with each? Take a moment to answer this question. How many handshakes do you get? Well, some of you can continue with this table, right? You can continue with this table and go from 5 to 50. That will take about 10 minutes, right? But do we have some other way of doing it? Yes, we do. We have listed everything in the table and we know we can write down a pattern rule. The numbers which we are looking at is sum of natural numbers, right? You can say whole numbers. You need to include 0 for whole numbers. So let me write down 0 here. I'm writing it purposely here just to tell you that the natural numbers, let me write numbers like this, are like 1, 2, 3, 4. Is that clear? But when we talk about whole numbers, then we include 0 in it. Okay, today's lesson will restrict ourselves to just whole numbers, okay? And then soon we are going to cover all the real numbers and we might talk about the imaginary and all others. Okay, so basically the idea here is to complete this, and for 50 it should be what? 1 plus 2 plus 3 plus 4 and up to what? 48, 49 or 50? What do you think? Till 50, right? So no. It is 49. One less. So the key word here is one less. Why is it so? Since we began with 0, right? 0 is also a number. So from 0 to n minus 1. You get the idea. So that is how we get our numbers. 1 less than. So for 50, it should be the sum of numbers from 1 to 49. Perfect. That becomes our solution, isn't it? Perfect. But how do we add these 49 numbers? That brings us to another question. If we know how to add it quickly, we can save a lot of time in any competition and beat the competition. That is the whole idea. Okay. So, that's what we are going to do. Learn a technique of adding these numbers. Okay, so I'll come to the solution later, but let's first explore this technique also. So let me discuss with you how do we add such series, right? There are two terms which I would like to say. When I just write the numbers with a comma, it is sequence, right? And when we do the sum, then we call it a series. So the idea here is series of natural numbers. Let's say n, series of numbers. Okay. So let us see how do we add long series of numbers. Well, so let's say the sum is s. Okay. So total we don't know, but we know it is a number. And what are we looking for? We are looking for adding these numbers, right? Okay. 48 and the last number is 49. Now this series is not going to change if I flip, right? So if I flip and make it like 49 plus 48 plus 47 plus so on, so this will be 2 and the last number is 1. I just flipped the whole series, correct? This sum has to be same, right? So we are adding the same numbers, makes sense. Now if I add, you see what I'm doing? I just add it. Then we get twice the sum, right? because I'm adding the series twice, but the numbers are what? 1 plus 49 is 50, 2 plus 48 is 50, 3 plus 47 is also 50, so we are getting all 50s. How many 50s did we get? Of course, 49. We added 49 numbers. So we get the sum as 49 50s. 49 50s. So we need to multiply them to get the sum. This little dot in between is the sign of multiplication. Right? Sometimes that cross looks like an x, a variable, which will be soon used in our calculations. Okay, so we'll just multiply them. So we are interested in finding the sum. We have to divide by 2 both sides to get the answer. So we divide by 2 and we know the answer is now half of 50 times 49. Or you can say half of the product of 49 and 50. Or in general, can you generalize this? So take a moment to generalize your formula or the rule, correct? So what we have arrived at is a rule, which is general, right? And we also call it a formula. So the whole idea here is that we begin with observations, we have questions, we start thinking, and then we work logically on that. We use the table in this particular case, and we derive a rule or a formula. And now we can answer this question at any scale. If there were 1,000 million people, whatever, we'll just multiply the two numbers. One is the number itself, and one is one less than the number. Divided by 2. Why? Dividing by 2 is like sharing, right? So when two friends are shaking hands, amongst two, there's one handshake. Share means divide. Perfect. So that gives you a fairly good idea of how we derived our result. Now let's look into it once again. So in example 2, we are looking into number of handshakes by 50 persons. So there was one option that was to extend the table, but that could take forever. And therefore, we chose to find a general pattern. That wasn't difficult. We have seen that the number of handshakes with 5 persons was the sum of first 4 numbers, and that gave us 10. And therefore, the sum of 50 persons should be sum of first 49 numbers. Now, the idea was, how do we add the 49 numbers? So we made a series, and we say, well, the sum of this series of 49 numbers is the letter S. Now here, I am using the symbol SN, right? So S, I'm saying, is for sum, right? So it defines sum. And this is number of persons. This is number of persons, correct? So that is how I have designed my symbol. It's kind of very important to choose the right symbols which are meaningful and which can help us solve. Perfect. So let's move on. So we added these sum of numbers in the reverse order, and then we found that it gave us all 50s. Since there were 49 numbers, there are 49 50s, but on the other side, we got twice the sum because we added the same series twice. When twice the sum is equal to 49 times 50, what is going to be the sum? Half of it, right? So we got half of that product and the result, which was 1225. Correct? Now, multiplication by 25 is very interesting and easy, right? So I'd like you to explore. So how do we multiply by number 25? And this 1225 will be very easy for you to calculate even without a calculator. So look into this. The kind of symmetry we have and the beauty of products of 25. In fact, you'll start realizing the beauty of numbers as we end our lesson today, right? We'll continue now. Another, give me about half an hour now. Okay, it's becoming interesting. Are you taking notes? Yes. Did you write the general formula for sum of numbers? What? Sum of numbers? Yeah. You know what? we actually learn how do we add n natural numbers in general, and the formula is the number itself times 1 less than the number divided by 2, and that gives you the sum of all natural numbers up to n. And n could be anything. It could be 50, 100, 1,000, million, or whatever. You got it. So we got our very first formula, and we also learned the technique of getting there. Perfect. Now let's move on. So the idea here is to correlate. If we relate our learnings, it is easy for us to remember and apply. Those things are very. Just learnings, you'll forget in no time. By the end of the lesson, you'll really enjoy, I hope, the lesson, but in no time, you'll forget everything which you have learned until and unless you make a note of the same, right? So let's make a note of all this, correct? So what we saw here is that there were two persons required for a handshake, zero handshakes with one person. Every new person shakes hand with those already present, and that gives us the series of natural numbers, and therefore we could count how many handshakes were there, right? So the tips here is that the strategic thinking is about connecting. Perfect. And we need to correlate the solutions with something you can remember. But you know how we can correlate this set of numbers? Well, actually, if you look at what was the result, let's go back and see the result also. So when we were looking at the numbers, we focused on the pattern rule. That is, how do we get the end result? But now let's enjoy the journey, right? What was the journey? Knowing the number of handshakes, correct? So when one person was there, there were no handshakes. With two persons, there was one handshake, and three handshakes when the third arrived. And on the fourth, we get three more, making it six handshakes. And then, with the fifth person coming in, we had 10 handshakes. Correct. So, the number of handshakes, look at the numbers there. It is 0, 1, 3, 6, and 10. That's what I'm trying to say, right? So, when we try to correlate, let us look into all the parameters of our table. So, we had this as 0, right? 1, 3, 5, 6, and 10. Right. So that is the sequence which we got of handshake within five persons, right? So one, two, three, four, 5 persons, 10 handshakes. We are here with a very, very important sequence. So I've written down here 0, 1, 3, 6, 10. Now, this is kind of important to understand. I'm keeping 0 aside because when we talk about sequences, we are actually normally taking the terms and the numbers as natural numbers, right? But don't forget, 0 is one of the key numbers. We'll keep it as a placeholder and therefore will actually involve whole numbers in our calculations today. Perfect. So you remember, make a pattern with coins, right? If you do not have a coin, there is zero pattern, right? So think about coins, right? So let's take quarters. So if you take quarters, place one quarter, you'll get a shape as shown here. Now you could place the three quarters in making a triangle, and then if you continue with this triangle shape, you will see a pattern being involved. This shape of triangle made with quarters gives you the same sequence 0, 1, 3, 6, 10, 15. You see that? And therefore, this is also called triangular numbers, correct? Try it yourself, right? So what are we seeing here is we are seeing quarters, like, and put these quarters and make a triangle. When you do so, what will you get? And how many quarters are there? So when you experiment this, you will see, well, that number will match with the number. in your sequence, correct? So we call them as triangular numbers. So now you remember the number of handshakes can be calculated, of course, with a formula which we just arrived at, and also can be correlated with triangular numbers. So we can solve many questions related to triangles with this concept and apply the rule which we have learned. So it works both ways. You get the strategy here, correct? So make a note of this. And now let's move along. Now this time I made the question very interesting. See how. So let's first look into the example 2, which says handshakes with some of them, not all of them. Now, Anil, Ben, Chandra, Dev, and Iran meet after a long time. They recalled that they recalled their first meeting at the birthday party. Then, the number of handshakes for Anil, Ben, and Chandra, and they were, let me write down separately. With Anil, there was one handshake, two with Ben. Chandra had three handshakes, and they've had four handshakes, right? That's what I've written here. So they recall when they met for the first time, they were not all friends, right? They were introduced in a birthday party. At that time, they had the number of handshakes were one, two, three, and four, respectively. So that means Anil had one handshake, Ben had two, Chandra had three, and Dev had four, right? Within this group, of course, right? Now, the question for you is that you have to use this information to find the number of handshakes for Irin. So that is to say, Irin had how many handshakes? So we have again converted this into a multiple choice question, which you might see in any competition. You get my point. So our learnings are directly related to performing better at any level. That is the key. Perfect. So I'd like you to take a moment and think about how do we figure this answer. We know that these are five friends as listed here, so we have labeled them Anil, Ben, Chandra, Dev, and Irin. I may call them as A, B, C, D, E. And we also know that Anil had one handshake, Ben had two, Chandra three, Dev four. How many handshakes for Irin? How do we do it? So let's do some thinking, right? Now, we can begin from anywhere. If I begin from Anil, saying Anil had one handshake, that means Anil could shake hands with Ben, Chandra, Dev, or Irin. Well, that doesn't really solve our problem, right? It creates more problem. If I begin with Dev, then Dev had four handshakes. So Dev had four, there are only four other people. So that should be perfect. Starting point from Dev. So Dev had four handshakes. So let's connect Dev with all four of them, right? So there you go. So we have Dev, and Dev gets all the four handshakes. Done. So that also gives you the result for Anil, right? So now we know how many handshakes Anil did. And it was with Dev only. You get the idea. So if you choose the right point to start, you're definitely going to get the right answer, right? You're on the right path. So it's a journey of learning. So we have to choose the right path. If not, we'll come back to the right path. Don't worry, it may be longer, but nothing is going wrong. So, remember one thing, participate actively, and remember, all the answers are right answers. There are no wrong answers in our discussions. Okay. So, we have worked out they actually shook hands with all of them. So, they was friend with all of them. Perfect. Now Chandra had three. So let's look into Chandra now. Chandra had three handshakes. So already Chandra has a handshake with Dev. That is perfect. Correct. That's already there. So three more means, well, it cannot be with Anil. Anil only had one handshake. So now Chandra has options, and they're clearly these. Correct. So these are the three options for Chandra, and that is it. So we are sure that Chandra had these three handshakes. How about, uh, let me choose another ink here. How about Ben? Two handshakes for Ben. Now, here, Ben is only connected with they for the moment, right? So Ben is only connected with they for the moment. So one. So the other one could be with whom? Chandra is already connected. The other one should be with Irin, right? So that completes our list. We know Ben shook hands with Dev and Irin. Now, do we have the answer for our question? How many handshakes for Irin? Look at it carefully and tell me the answer. I think it is very clear, right? You got it. That is the number of handshakes for Irin. Perfect. So see how we approach to this solution. So what we did was we had five boxes. We kind of labeled them with the name of each person and then started from they, right? Because we know Anil 1, Ben 2, Chandra 3, Dev 4, Iran. We wanted to know, right? Since we know Dev shook hands with all, we connected Dev with all of them. Perfect. And then we began looking forward for Chandra. Now, Chandra could have handshakes with the others, right? And total three. Not with Anil, because Anil already has been engaged with Dev, right? So they've connected with Anil right away. So that is also taken. Now left with Ben. Ben needs two handshakes, so Ben does with Aaron. Well, that covers the list, and clearly we know how many handshakes Aaron could do. So clearly from this particular table, Aaron is doing a handshake with Dave, and Aaron is doing a handshake with Chandra. So the answer here is two, right? So Aaron, two handshakes. Option C. Do you see that? So that is how quickly we can come to the conclusion. It was a very difficult question, right? So that is key. So let's start with Dave, who had four handshakes, and so we get the result that Erin had two handshakes. Do you like it? Another approach we have learned, logical approach, where the critical point is from where to begin. If you begin from the right point, the solution is very easy and it comes in fewer steps, right? Now, let's say, coming back to a story, which was about the five friends. Now, at the end, they want to take a picture, a group photograph. So they stood in a row for a memorable group photograph, right? Now, again, the question here is, which comes to your mind, in how many arrangements could they stand to take this moment? Right. So the question is, in how many ways can the five friends stand in a row for a group photograph? Again, five options are given to you. Can you answer this question? How do we answer this question? Well, one way is you start making the list. Anil, Ben, Chandra, Dev, and then shift one by one the persons, right? And keep shifting them. And you will get all the options. That's definitely a good way of doing it, but it's going to take a lot of time. Can we logically approach to this using our numbers? Okay, so you could do this, but I think we need a better way of doing it. What could be a faster way of doing it? That is the key. So that's what we are going to learn. Let's brainstorm. Brainstorming is a very critical part of critical thinking. So when you have some observations, a question to work on, brainstorm and think the possibilities. Well, my approach to this is, since we're talking about five friends, let's take these five boxes, right? So we have these five boxes: one, two, three, four, and one, five. Now that is kind of arrangement in a row, right? So we just put these boxes in a row, and let's see how many persons could take the first position. Well, there are five friends, so any one of these five could take the first position, right? Now let us say Anil takes the first position, right? In that case, how many could take the second position? Well, there are four left, right? So any one of those four could take the second position, right? In that arrangement in a row. Then we are left with 3, 2, and 1. Now, for Anil standing in the first position, all those will be the combination. So they get multiplied. And therefore, the result should be what? Result should be product of these numbers. Do you see that? This time, the result is the product, right? A very big number. So do you get? It's not that difficult, isn't it? Yes, you're right. And clearly, that gives us the answer. So when you multiply, you get your solution, right? So that is how we could do it. Brainstorming really helps to solve such questions. So here is the solution. So for the group picture, we are saying that these are the five positions, and in the first position, there are five choices, right? And the second, there are four choices. Then we have 3, 2, and one choice. Product of these will give us the result. Perfect. So the summary here is that the approach to find the possible number of persons for each position works. Correct? Yes. Any of the five person can take the first position. Then, for the second position, we are left with four options. Likewise, 3, 2, and 1 for the remaining positions. So the total number of ways is product of these numbers. We'll just multiply these to get a result. Option E, 120 handshakes will take place. Oh, sorry, 120 ways for them to stand in a row for the group photograph. Perfect. Do you see that? So, with this story, we came to an example where it was the sum and now it is the product. So, that is simple arithmetic which we can all do, right? So, that brings us to the end of the story. They had a good picture, good time, and then they went off. Now, the important thing here is looking back in our notes. What do we have there in our notes? That is another important thing. So, get ready. I'm going to share my notes and also see your notes if you are willing to share with me, right? Now, here we realize one thing, that this time we are doing product of numbers, right? We are doing product of numbers. Now, if instead of 5 there are 100 people, oh, 100 is too large, let's make it small. Okay, if instead of 5 there are 10 persons, then how many handshakes? Then it will be 10 times, 9 times, 8 times, 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1. You realize why 100 was a big number? I didn't want to write 100 numbers, right? So that, there should be a shorter way of writing it, correct? So in mathematics, we have a shorter way of writing it. We call it factorial. So 10 factorial means that. So this is a notation. So we'll call this as factorial notation. So if I have 100 persons, I will say 100 factorial. So you have to read this as 100 factorial. So that is the factorial notation which I wanted to introduce to you at this moment. So many times when we are counting, we are actually counting lot of numbers. So we are going to learn new ways of writing those numbers. We cannot be writing all over the place. We could write 100 factorial as shown here. So that is the thing which we'll now look into. This notation itself. So I call this as factorial notation. Now it's called L factorial notation, and it is written as n factorial with that exclamation mark. So n factorial is a short form of writing product of positive integers from n to 1, right? Or from 1 to n. Either way, you could say. For example, just now, we saw what 5 factorial is. 5 factorial is product of 5, 4, 3, 2, 1, and the result is 120. Similarly, we could calculate what is 10 factorial. Now, you could use calculator for this. Most of the time we are not using calculator, but for these calculations, use a calculator. Wait a minute. Do we have this factorial on a calculator? Well, sir, you need a graphing calculator or a scientific calculator, which will definitely have this, right? So when you look at the key, which is like this, let me just make this key here, and there you will see the factorial notation as written here, right? So that is the factorial notation normally used with the shift key. So if you find that on your calculator, you can actually calculate these numbers, right? So I like you to use a calculator, figure this out. But for the moment, here are the results. If I want what 10 factorial is, I get a number which is 3628800. If I do 15 factorial, I get something like this, 10 to the power of 12. What is that? Well, that is a trillion. Oh my God. 15 factorial is the order of trillion. 18 factorial, I don't know what it is going to be. It is to the power of 15. Oh my God. Quadrillion. Oh, what am I learning? 20 factorial is power of 18. Quintillion. Oh, so these are very big numbers. And these numbers have ways of representing, just as you know, 100, 1000, million, right? Trillion, billion. You get my point, right? So these are the other big numbers which we get into. And you see this factorial notation? Such big numbers just written as 20 factorial. Perfect. In general, if I say n factorial, it really means n times n minus 1 times n minus 2 up to 1. So it's a product of numbers till n. That's what it is. Okay. Let's take up an example, a difficult example, because now you know how to write factorials, correct? So the question for you here is, you need to calculate this. 5 factorial times 9 factorial over 12 is n factorial. Oh, wow. You have to find the value of n in this particular equation. So that becomes kind of a question for you. Make a note of this. Let us see if we can solve this, right? So I've taken a very difficult question purposely because I'm not taking many examples on factorial, but a kind of interesting question is here. So let's get back to our example, which is we need to relate the left side, which is 5 factorial times 9 factorial, and we have to write this as factorial of another number. How do we do so? So we have 5 factorial and 9 factorial. Well, 5 factorial, can we write what 5 factorial is? You know what it is. It is 5 times, 4 times, 3 times, 2 times 1. Correct. Well, in the denominator, we have a number 12, and on the right hand side, we have 1 in the denominator. We want n factorial, correct? So that means that we have to take away the two numbers whose product is 12. And those two numbers are 4 and 3, correct? 4 and 3 gives you 12. So what we did was that we took away the product, which gives us 12. And therefore, we wrote 5 factorial as 10 times 12. You see that? So 5 factorial we wrote as 10 times 12. Now the question is simple. So we can now write what is 5 factorial 9 factorial over 12. Since 5 factorial is 10 times 12, we wrote that and multiplied with 9 factorial. And at this stage, you can clearly cancel 12, so you're left with 10 times 9 factorial. Perfect. And what is that equal to? Well, that is equal to 10 factorial. Does make sense? Is it? See what? 10 times 9 factorial is what? 9, 8, 7, 6, 5, 4, 3, 2, 1. Well, if I have to write this, I will write this as 10 factorial. That is how we get 10 factorial. And clearly, we get n as equal to 10. Very complicated question at this stage. So I'd like you to review this part and see how we have introduced to you a very good notation, the factorial notation, to take care of very big numbers. Correct. Now, let us share the notes. Can I see what have you written? Okay, tell me. What have you got in your notes? Perfect. Now, here is how I actually recorded today's lesson. And what I see here is that we're talking about thinking and connecting. That was the key for us. And the key words to begin were explore, observe, investigate, visualize, and discover. We started with the handshake. We looked into a pattern which kind of made triangular numbers. You could arrange quarters or coins, many coins which are round, right, in a way of making triangles. And when you count these numbers, you get the numbers 1, 3, 6, 10, 15, and so on. And of course, if you don't do anything, you get 0 there, right? So that's 0 beginning. So we came up with the rule, which was n times n minus 1 divided by 2, and definitely to get a number there, natural number, and has to be greater than 1. But if it is equal to 1, you get 0, which is also a part of our pattern. Correct. So that becomes a restriction on the formula which we have derived. So every formula comes with some domain. So what we're learning here again is that when we have a formula, we have restrictions also, right? We cannot apply it everywhere, right? For example, if I put n as minus 1, it is not going to work in this particular situation. Okay, so restrictions are there. We say the domain of our formula, right? So that's again a new term where some of you can make a note of, right? So we came up with this. The whole idea was to look back and analyze and to generalize our solutions so that they can be applied. So that's a key thing which we learn. We also learned a strategy to add a series, and the strategy was to reverse and add to get twice the sum. So when you get twice the sum, you have to divide both sides and you get the result. So divide by 2 came thereafter. Perfect? Right. So apply the strategies to reinforce, and that is why we have examples after examples. And to reinforce, what am I going to do? I'm going to add assignment to you, right? So that is the reason why do we have assignments. So I'll appreciate if you could actually take up the assignment and solve all the questions. We'll discuss this in the next class. Perfect. Now, while working on a situation, there could be variations. For example, in the handshake, the variation was what? When they met for the first time, they all didn't knew each other, right? So there were limited number of handshakes, and we want to figure out how many handshakes for Erin. Perfect, that was it. And in doing so, we also learned a new notation, which was factorial notation. Such a great thing. So factorial notation helps us to write very big numbers in no space. I shouldn't say no space, in a very small space. Correct. So we have to be specific in mathematics for this class. We can, kind of. We are coming to that stage, right? That's our learning process. So I hope you're enjoying this journey of learning. Right. And make a note of this, make it memorable, just as the last picture the friends took. And when you take a picture, the number of arrangements was the number factorial. For 5 persons, 5 factorial, 10 persons, 10 factorial. But remember, this could be a huge number. So if there is a group picture of the friends in a class, it could be like a very, very big number, right? So you need to explore working with factorial notation as we did with one of our notation, right? One of our example we did that was very critical. So that is what it is. That brings us to reinforce learning. The key here, which I want to really highlight, is your passion of learning, right? So the thing is, you should be really passionate, right? So if you have passion, only then you could have continued with me for so many minutes, right? So passion of learning is very important. And definitely perseverance, right? So that is what brings us to the key term, and that is the grit. So, you should all be very passionate of learning, and then you can really contribute and excel. Right? So that brings to almost the end, but here is an assignment for you. So here's a note on assignment. What I've done is, based on today's learning, thoughtfully, I've given you a few examples. These examples will help you understand what we have learned today, reinforce your learnings, right? Apply these things. Perfect. So I'd like you to make a note of these assignments. You can see now on the screen clearly three questions. Perfect. So take a picture of these three questions. Here is the fourth one coming for you. These are multiple choice questions, some of them, right? So one of them is not correct. The others are. So take a picture of these multiple choice question because we want to beat the competition. That's the whole idea. For many students, that may be the target. So this is the list for all of you. So at least you need to answer the four questions. Now that is the extended set of list for some of the math enthusiasts who really want to compete. So we have some challenge questions for you. Question number 5, 6, and 7. They are very difficult questions at this level. I'm saying you're in grade 5. Can you do that? So come back to me and let me know how many of you are interested in joining our second class, in which you know what we're talking about? Pascal's triangle, right? We'll talk about Pascal's triangle. So that becomes the extended set of questions for you. Now, to really beat the competition, we have gone a step ahead. And this is extended preparation for the competition itself. The questions which you now see are normally seen only in high level competitions like Olympiad, right? So worldwide we have these competitions and these set of three questions, which brings in all the set of 10 questions for you, right? Multiple choice this time again. It helps you to check whether you're on the right track or not. Perfect. So I hope you have taken a note of this. And it's not just that. So my classes are packed with lot of material. So just not these assignments. We'll also share with you many websites and links and so many other my videos if you get back to me. Perfect. But here is a project for all of you to do. So this project really depends on how do you visualize and count. A very interesting project. So I'd like you to take a picture of this project, the screen, try it yourself. Now, in the next class, you could actually discuss how you attempted the assignment, how did you do the project. You can also form groups, right, so that we could have a group discussion. So the idea is also, I'll really encourage you to form groups and we could have a group discussion, right? Is that clear? Did you really enjoy today's lesson? It was fun for me teaching all this, rather, I should say, sharing my love and passion with all of you. And I was so happy with your active participation in today's lesson. And I hope it continues. And what are we going to do next? We are going to understand what is Pascal's triangle and connect, right? The connection is the triangular numbers, as you can see on a Pascal's triangle. I've already highlighted the numbers 1, 3, 6, 10, 15, and so on, which we call triangular numbers. Perfect. So that is going to be our next session. Next week, same time. Perfect. Now here are my notes at this stage. So what we did is all what we did, right? And then we have some notes here. So share your notes with your friends. That helps to reinforce learning. With that, we'll end our session. Thank you and have a great day.